Well, good day, Internet. This is part 3, the wrap-up of when you find your bike's hard to start and you're looking at, specifically looking through the ignition system. There were a few odds and bits that I left out, and I've done some more research, but this should wrap it up. So I'm going to look at the CDI box, the black box. It has a couple of names, but it basically controls the ignition system, and it's a sealed black box that is basically non-repairable. Come up with a few tests we can do on that to see if it is truly failed or it's broken. I'm also going to look at the pulsar or pickup coils. Sometimes in the automotive world they call them crank position sensor. Yeah, it's basically telling the black box, feeding back to it, where the engine is mechanically and whether it's at the position to fire the spark plugs. So we'll look at that too, and just look at another component sometimes in the ignition system are the relays, which are electrical switches of sorts. So I'll look at those a little bit. Well, like I say, this is a wrap up, and then there are a couple tips and tricks along the way. So stay tuned, and here we go. So what we can do to test the black box further, assuming we've completed all our ground tests and ignition tests up to the black box, the CDI unit, and we're suspecting it's the problem. Again, we're going back to testing the grounds, but a little more intense. So we'll skip over to the circuit diagram here, or your wiring circuit. And the ICU is there, and the green line coming out of it is the ground. So trace that back to the ground on the motorcycle and make sure it's functionally correct and there's continuity there, a good ground in other words. And then we move on to that ground line as it comes out of the black box. You test to every single other line, and there should be no connection there. So it should read in whatever your scale reads to infinity. So it's saying that there's no continuity. If there is, then that's probably an issue because I believe the circuits are designed to isolate the ground. So another kind of a test of the black box itself is to look on the back. They're usually sealed with an epoxy resin, so the circuit board and whatnot's put into a little shell, and then the epoxy resin's poured in top and sealed off. So what you can look for is blistering or obvious signs of something burnt, something's gone wrong, the electrical components. Other than that, there's not much. You can give it a sniff maybe, but if you're going to see burnt or bulges, it's probably pretty noticeable. So that's about it with the black box. I mean, the other one is swap in one that works, but I mean, that's if you have that opportunity, yeah, go for that, but that's pretty rare. So I think that's about all we can do with testing the black box, unless, like I said, the service manual has specific readings that you can test the voltages and whatnot. Moving over to the coil pickups or the crank position sensor. So what you want to do here is find the colors of the wire in your wiring diagram. Then you're going to have to physically go to the bike and find where that pulsar unit is. Usually under the side case, left or right, on a inline twin or 4, or V4s too. It's usually put under a side cover, and the wires will come out of there. But you're looking for the where it goes back and terminates at the black box. So you pull off that connector, and then what we're going to do is just basically test resistance between the paired lines. So in this case, we have a blue and a white with a blue stripe, it looks like. So what we want to do is just test the resistance and take the number down. And then we're going to go over to the other pair, assuming you have two, and test out that resistance. And logically they should be the same. If they're vastly different, then you can assume one of the other has gone. If they're both the same, I think you can 99% of the time be assured that they're both okay. Now the other option there, they may have physically come loose and are out of adjustment. That's possible. So again, depending on your bike, have a look at the actual physical mounting and pull a side cover off if it's easy enough. Okay, back to the wiring diagram here. What we're going to do is have a look at a typical relay in the system. So this whole device here is called the starter relay, and the guts of it are really in here. This is the low voltage coming in, your 12 volts side, and it's connected back up to the start button And what happens is this low voltage will come in, energize this coil, and send these contacts out to here and here, energizing the high current, high voltage side of the circuit. So between the starter motor and the battery. So that's how a relay works. Is basically a low voltage switch operating a high voltage switch. Okay, so to test a relay, we just use some 12 volt power from a battery, ideally. In this case, this is from the Honda Goldwing, of course, and this is the incorrectly named starting solenoid. It's actually a relay in here, triggered by the back two leads coming from your starter button, allowing the main current to run between these two leads, which is this is the battery, and this goes down to the starter motor. So this is heavy cable, but again, this is a electric switch, a switch operating another higher amperage switch. So to test this, basically, it's a 12 volt relay, so watch out, there's some 7 volt relays on the Honda, for example, so you don't want to put 12 volts through it. To test this out, we got our hot 12 volt leads coming in here, and we know that it's the back terminals in here. So you'll probably be able to hear this. Bit of a spark, but not to worry. But we hear that click. That's the relay inside working correctly. So again, back to the wiring diagram, you can see their little schematic here, how it works. There's a coil that's operated by the 12 volt power coming through that pulls the main switch together and allows the high amperage to go through here, the high current to go through these larger lines to the starter motor. So in a nutshell, that's a relay, and of course if they're broken, nothing works, and there can be a number of them through your ignition circuit that could be coming into play. So check those out. Okay, I just want to mention the multimeter, good tool to have, and I think I mentioned this before. What you'll want to look for is a rubberized case, I would say, and also a digital display. The one thing I noticed here is just wrapping up the last episode, and I just gently picked up the lead, and this thing just fell apart on me. So there you go. No way to fix that. So the one thing I noticed too in the store, I was looking for new leads. You can actually buy these meters with the leads permanently attached in the bottom, which is a big no-no as far as I'm concerned, because if something breaks, you can't replace it. And also I noticed that in the store that they're still selling the ones with the analog little dial meter in there, which harder to read, and just by the looks of them, they don't look like they'd survive just unpackaging. They look so cheap, just hard plastic and a little dial. I'd avoid those for the price of a few more bucks. Get one with all the functions and a little rubberized case, and I would just say make sure you can replace the leads. Well, that just about wraps up the ignition checks you can do. A couple little tricks I was just thinking about. If you, it never hurts to do this. Get the darkest place you can find, and if you can turn your headlights off, that'd be good too. But run your bike in the darkest place you can find, and have a look for arcs. Like you'll probably see, if you're going to see any, you're going to see blue arcs jumping around the ignition high tension lines, and it's quite surprising. Sometimes they'll just come out and randomly jump out of the high tension wires, and you got a problem there, so it's time to replace those. And you may see them other places too. Another little trick there is if you got problems running in moisture and wet weather and things go a little crazy, you can just bring out the spray bottle and simulate the wet weather when it's dry, of course, when the thing's running good, and just methodically go from one end to the other, so you can hopefully isolate where the water problem, moisture issue is on your bike. So that's another good little trick. Instead of waiting for it just to run crappy in the moisture, bring out your portable moisture application device here, a little spray bottle. That's about it for now, and hope that helps somebody out there, and take her easy. We'll talk to you soon. Bye for now.